Welcome to this session. So I'll start with the data science. Before I get into what is data science and what are the nitty-gritties of data science there, I would quickly like to introduce myself. I'm Pankaj Gupta and I have 13 years of experience into IT and business analytics domain. So we'll start with this session now. The first thing that we have at our hand is what is the agenda for today. So we will see in the first part that what is the need for data science? Why are we actually involved in data science? Why do we need to study data science? Then second, we will see what is data science. So in first part, we'll cover the need, where does it come from? And then what actually it is, how does it solve the problems that we have? And we will then see some use cases of data science, how it is used in the industry, what kinds of problems we actually solve using data science. Then we'll do a comparison between business intelligence and data science. So business intelligence is a study that is being in industry for quite long, which is now being replaced by data science, or being, I would not say replaced, but actually complementing business intelligence. So it is taking business intelligence to one step further than what business intelligence used to do for us. Then we will also see some of the tools that are used in data science, some technologies that data science employs, and what do we need to learn to actually master data science. And finally, we will see that what is the life cycle of a data science project, or what is the approach that we follow in solving any problem using data science. So this is the agenda for today. So what is the need of the data science? This is a very important graphic that shows what actually led us to data science. So we had data storage in traditional form earlier, where we had a lot of data stored in unstructured form as well as structured form, I would say. And then there was a lot of data flow happening. So if you look at today's time, then the data is actually getting created faster than we can actually imagine. Whenever you are traveling on road, there is a lot of data that is being created. The speed of the traffic, switching on and off traffic lights, and then you see on your Google Maps, everyone is using nowadays a lot of Google Maps, and then all the data of the traffic that is flowing on the roads is actually captured through satellites and transmitted real time to your handheld devices, where it is actually telling you whether the traffic is more in one particular locality or it is less, or is it favorable to go into that direction. And then you also get suggestions on which route to take and which routes to avoid. So there is a lot of data being created as we do our day-to-day activities. There is a lot of data being created at every point of time. So the problem is that we were not doing anything of that data. So there was no decision making, there was no prediction. So whether it would be wise to go out on this point of time, or I should avoid and take my journey at later point of time. So all of that kind of analysis was not available. As we were creating data, we were not using that data in earlier times. So and there was lack of scientific insight. So even though there were data and we were doing some sort of reports, like if you look at some organizations in corporate world, we are doing a lot of reports like utilization, what is the resource utilization, how much we are spending. But out of that data, even from those reports, we are not drawing any scientific insights. Like for example, we are not using that data for forecasting. So if we have to forecast that what would be my sales based on my previous data, then that was not being done. Now what data science has enabled us to do is that we are moving from an approach where we had reports that told us what is the situation, the picture of the present condition looks like, to more of a decision making and predictive approach. So now we are actually moving from an approach where we could see the actual status, what is the current status, versus what actions do we need to take moving forward, what will be profitable, and how we are actually moving into a direction where all of this data can help us in taking decisions. It can also help us in making predictions. So for example, if I am a shop owner and if a person wearing a red shirt aged 25 to 35 years and definite profile would actually be interested in my products, so I can all do that based on the data that I have stored in my computers for last few years. We are also able to do some pattern discovery. We are able to find out if there is any pattern in the data. Like there are a lot of sales happening in the months of November and December, primarily because these are the festival months in India. And a secondary reason can also be because there is weather changing, there is change of season. So there are a lot of sales happen during that kind of season. So we are able to actually draw a lot of patterns from data and do those discovery. This is what leads us to data science. So this is where we actually draw a need of data science, that how do we actually analyze all of those data? How do we find out what are the hidden patterns in the data, and what predictions do we make based on the data, and what are the decisions that we take based on the insights that we draw from data. So this is where the need for data science comes from. So still continuing on the need for data science, what we had earlier was structured data stored in form of databases into like our RDBMS like Oracle or MySQL that were used to store structured data. When the data grew a little bigger, then we started using data warehouses, where we had a concept of storing historical data and transactional data separately. So whereas the transactional data was stored in our databases, we had large pool of databases which we called data warehouse, where we used to store all our historical data. And then what traditional BI does is that it acts on the data warehouse and it generates some insights or some reports or some graphics that are actually predetermined reports only. So month on month we generate the same kinds of reports that shows the current picture at any point of time, and it does not go beyond that. It does not explain the underlying reasons or the causes that are responsible for creating such results. But now what has happened is that if you look at the bright graphic below, we don't only store structured data, we are also storing a lot of unstructured data. So what is the difference between unstructured data and structured data? When we talk about structured data, then it is organized in form which can be stored in database into rows and columns. For example, if you recording the transaction, the sales transactions at any point of sale counter, that can be marked as structured data. Like you will have transaction ID, you would have the list of items that are sold, then you will have the quantity of each product that is sold, the price per unit for each of the product, and then the total cost of that particular product. And then of course summing it up to what is the total cost of one transaction. That is a structured data. But we also have unstructured data, which is like data obtained from your Twitter feeds. So let's say if I purchased a pair of shoes from Adidas and I did not like it, and on Twitter I just rambled my emotions and I said that I purchased a pair of shoes from Adidas and they are of very poor quality, and I put a hashtag there, hashtag poor quality Adidas. So this becomes my unstructured data because there is no definite format of this data. I can post any data in any format, whichever I choose. There is no nomenclature for the kind of hashtags that I am going to put. There is no restriction on what information I am going to put and what is the form of that information. So that is unstructured data. So we are also analyzing and storing a lot of unstructured data besides structured data. And then we have Hadoop, which is nothing but actually used to store big data. So big data has become a term in itself. So earlier we used to have 1 GB or a few MBs of data available that could easily be stored on a simple hard drive. But now we have humongous amount of data which cannot be stored on a single secondary storage device. It has to be distributed, it has to be stored in multiple computers, it has to be stored on cloud, and it has to be accessed in ways which were not in faster ways that our traditional data access systems do not allow. Then we apply a lot of data science algorithms. We just do not do a simple reporting as we used to do in traditional BI. Now we are doing a lot of data visualization. We are seeing what data speaks. We are looking into the stories that the data tells us. And then we are doing a lot of scientific discoveries based on those data. It is not just predetermined reports. We are doing a lot of ad hoc queries also. So we are able to actually forecast what is my sales going to look like. I am able to forecast that how many of my customers are able to return the loans that they have taken, and a lot of different kinds of scientific discovery we will see later that we can actually do using data science. And this is just to summarize where we can use data science is number one, to recommend the right product to the right customer to enhance business. This is a very great example, and this is how we are actually using data science a lot into retail domain. So whenever you go to a mall and if you go to stores, big stores like Lifestyle, or Shopper Stop, have you ever wondered why are the clothes placed in a definite order? What are the items that are displayed on the counter? How they are actually stacked up in the counter? Which items are placed right in front of you? Which items are placed at a shelf which is lower than your eye level? Which are the items that are placed just in front of your eye? And what are the other items that are placed on top of your eye level? So it is all based on data. Whichever products sell most are more attractive, or the stores want to sell the most, they are kept in your level of reach. Rest of the items that are not frequently sold or they are not very attractive from a margin perspective, they are actually stored at the lower levels. There is a lot of data science that is involved. Then there's a wonderful story that I would like to mention over here is that it was found in Walmart that on Fridays they have a lot of sales on diapers. So a lot of babies' diapers were sold on Fridays, Friday afternoon specifically. And also they found from data that a lot of beers were being sold. And from looking at the sales data, they were able to make out that they were part of the same transaction. So people who were actually buying a lot of diapers, they were also buying beer. So now if you talk about there is no data, then it is number one, very difficult to find out there is any correlation between sales of baby diapers and beers. And second, it is very difficult to find out that what is the reason of those sales and should those sales be promoted and what are the ways of doing it. So looking at sales data, they were able to find out using their data science mechanisms that babies' diapers and the beers, they sell a lot on Friday afternoons and they are often sold together. And so just consider that Walmart, a store like more than 1 million products, and you are able to draw insights on these two particular items, how difficult that would be. They found out that a lot of shopping on Friday afternoons is done by males, and that too people who are actually working from home or they are taking a Friday off. So a lot of gents come to the Walmart store and probably they are assigned a duty by their wives to buy baby diapers. And when they actually land up to Walmart store to buy diapers, they also end up buying some beers. So it would be a good idea that those beers are co-located with the baby's diapers and the counters are not very far from each other. So Walmarts typically have shopping area in square kilometer or 2.5 square kilometers, a mile square kilometer. So it was considered that it would be beneficial if they keep some beer racks next to diaper bins so that people can easily pick them up and they enhance the sales of their beer plus diaper combinations. Similarly, they can be used to predict high LTV customers and help in customer segmentation. So we can do segmentation. So LTV is nothing but loan to value customers. So banks and financial institutions, they can do a segmentation of their customers and predict the characteristics of customers who are more likely to return their loans in time and who are the better customers to actually approach for loans. So you might have seen that there are a lot of calls that are made to you on phone that please take loan from us. We are offering personal loan at this percent interest. So these are not the calls that reach to every customer. There is a lot of data science that goes behind the scenes and they figure out that this is a segment of customers who are actually having good income to return the loans with the interest that they are demanding and so on and so forth. Next is in machines. You can build a lot of intelligence in machines by collecting a lot of data. So this is used very widely nowadays. Our cars are getting smarter. There are a lot of features that are coming in car, like cruise control is one of them. That how do we maintain a constant speed despite the environment conditions? There can be roads that are on high slope, then there are roads that have very steep slopes downhill. So still you are able to control your speed. Similarly, there are very advanced features now coming in cars, like you are able to identify whether it is becoming dark, and then there are automatic headlamps that glow up when it starts to go dim in the evening. So these are all intelligence that is built up in machines. You can also use the data science for predictions. There are a lot of transactions that are happening in one particular account very frequently, then it can be a cause of worry. And looking at the data and drawing insights from the historical data, they are able to find out that it can be fraudulent, and then they can take immediate measures in real time to avoid those kind of transactions. Similarly, there is a concept called sentiment analysis that is used to predict outcome of elections. In one of my projects, I worked on sentiment analysis for the floods that came in Chennai, and we use that to identify which are the areas that are in serious need of some help to be provided, or the areas where the help is not reaching. So this is where we see that there is a big need of data science. Now we actually move to what is data science. So data science, by definition, is a blend of various tools, algorithms, and machine learning principles with the goal to discover hidden patterns from the raw data. So we have data coming from multiple sources, a lot of information being collected, as I just mentioned. But then what is the use of that data? How do we use that data? To use that data, there are some statistical algorithms that we use to figure out that what is the story that the data is telling. We use various tools that are prevalent that help us in identifying those patterns in data sciences in the data. And we also do a lot of predictions using data science. So it is primarily used for decision making and predictions. Now let's understand the data science with the help of some examples. So we had the definition now, but let's move on to some use cases where we can see how data science actually works practically. So data science is very widely used in sports analytics, and if you are fond of watching cricket, then you might have seen that there is a lot of data coming in. So Virat Kohli batting second most of the time against opposition of this kind, against subcontinent opposition, scores double century in every 3 matches. Whenever he scores century, 80% of the time India goes on to win those matches. So these kind of statistics, these kind of insights are all generated through data science. In basketball, teams are actually using data for tracking team strategies and outcome of matches. You'll be surprised to know that even the height of the players in basketball, there is a correlation drawn that if the team has a lot of tall players, then what are the chances of winning in basketball? And if there is a particular player playing in this particular game, then what is the probability of their basket scoring? And what should be the approach that should be taken? If this player is not playing, if any other player is playing in his place, then what should be the strategy of the opposition team in that case? So there are a lot of analytics that goes in sports. There are a lot of parameters that are used, like average pass time of the ball, number of successful passes, speed and accuracy of the successful baskets, and area of the court. It is art of sports has now transformed into science of data science, right? So there are a lot of data science being used, and there is a person who is constantly looking at his computer and drawing all of these insights and sending signals to people playing in the code as well. In e-commerce, data science is being widely used. So Amazon, for example, has a huge number of consumer purchasing data. So Amazon has trillions of rows of data that is related to anything and everything that you do on Amazon. So there are customer profiles, there are purchasing capacities, there are histories of each and every customer. They have actually segmented the whole customer data into different buckets, and now they know that this is the bucket of customer who is more prone to buying ready-made clothes, this bucket of customer who is interested in reading more books, and we can offer some new books to this customer and is more likely to buy that. So there are a lot of data, huge amount of data that Amazon.com processes. Then there is also information like addresses. There is an office address, there is a home address of people where the things have to be delivered. Then there are routes on which it is more efficient to actually send the stock. And not only on the customer side, also on the supplier side, and also on the logistics side, there is lot of information that is maintained by Amazon, and that is all done through big data storage approaches like Hadoop. Based on this data, Amazon actually does a lot of drawing insights and decision making. You would have seen that whenever you go to buy any object, then you also see some recommendations that people, if you buy this, people generally buy these additional things also from Amazon. Also, then there are some recommendations that if you buy these 2 3 things together, then you get a discount on the total purchase. So this is where Amazon is using. Google is now developing a self-driving car, and this is something that people have been waiting for a long time. So Google is developing driverless car, which would be very smart. So how it would work is that it would collect data in real time through the environment surroundings based on several sensors that would be located in the car. And these sensors would collect information like temperature, weather data, the road condition, the traffic condition around, and then it will take a lot of decisions like when to speed up or speed down, or when to overtake and when to turn. So all of these decisions the car will be able to take itself. And this is where the data science is coming into picture. So before we move into more formal use cases, more industrial use cases of data science, so we will move on to some more use cases of data science. And I would just take a few of these from travel, let's say. So in travel, it is very widely used nowadays for predicting flight delays. So there is a site in US that collects the data for all commercial flights. It is publicly available. I don't remember the name of that site, but there is a site that collects the data, and it has data from 1986 to till date of all the commercial flights that have taken place in USA. And based on all of those flights data, it can actually be predicted which are more reliable flights and which are more likely to have delays. And that is done on basis of several different parameters, like the source, the destination to which they are flying to, the weather conditions in those areas, whether they are geographically suitable for flight travel or there is a lot of turbulence, then the average wait time that is there, the number of planes that airlines have, and a lot of different parameters come into actually deducing that what would be the predictable, what would be the predictions for the flight delays. Similarly, flights, they actually also do a lot of dynamic pricing. So you might have seen that during the weekends, the prices of the tickets, they go down. And just before Monday morning, because there are a lot of people who take business flights, prices go up. And during the week, the prices again go down. So a lot of dynamic pricing is done by using data science. Then in healthcare, it is used very widely. It is used for disease predictions. So there are a lot of tests that are conducted, and based on those test results, you actually predict whether a person is likely to have certain disease or not. Then you also use data science for medication effectiveness. So medication is given to sample of population, and then we see that what is the result of that medication. And based on those results and doing a lot of analysis, we are able to actually predict whether this medicine would be effective or not in treating people. It is used in sales for offering discounts and for demand forecasting. So looking at the trends of sales that over the last few months or few years, we can actually accurately forecast that what would be the demand for certain products. And for this, we not only look at the historical data, we look at seasonal data as well. So for example, if there were more sale in February, we cannot say that we would have similar sales in the month of March. And for that, we actually go back to several years and look at how the sales has been during this day, during this month last year, and what were the circumstances at that point of time that helped us in achieving that particular sale, and what are the decisions that we should take now to increase that sale or to take it to a different level. So in credit insurance, it is very widely used. We see that who are likely to actually return our loans on time, and also look at people who are likely to default. In one project that we did for banks, we were actually able to predict the number of dead accounts. So dead accounts are the accounts in banks who people actually do not use. So everyone mostly nowadays have multiple bank accounts, and we do not actually use all of those accounts. So myself, for example, I have 5 bank accounts because as I changed jobs, in every job, a different salary account was opened for me. 2 of those accounts have become dud accounts. I do not operate those accounts. So banks actually had to spend a lot of money in maintaining those dud accounts. And what they want to do is to recover those dud accounts. So if they reach out to each and every person who is holding a dud account, that would again be a very big cost. So in a project, we were able to identify a subset of those people who had dud accounts and who were more likely to reactivate those accounts based on their transaction history in the banks. So we found out that people who had relatively less amount of money in their accounts, or who had larger amount of money, and they are more likely to have those accounts activated if we provided some incentives to them. So a simple RD opening or simple suggestion of opening a fixed deposit can reactivate those accounts. So insights like those were drawn. Women were found to be interestingly more prone to, or more feasible customers for reactivating their dead accounts. So these were all the insights that we were able to draw and suggest our customers. Self-driving cars we have already seen. In social media, there is a lot of usage of data science, and whenever you are actually posting pictures on whatever you are doing on sites like Facebook or WhatsApp, they are all being recorded and monitored by these companies, and then they actually show you relevant ads based on what you are doing on Facebook. Even if you are fond of traveling, if you are joining a lot of travel groups, or if you are a fitness enthusiast, if you are into a lot of fitness exercises, then you will get recommendations of relevant events related to your interest, and also advertisements related to your interest. So all of your data is being tracked, profiled, and managed into several groups. A segmentation is done where it is being used. Now actually move on from the use cases to what are the skills that are required for a data scientist. So to become an expert data scientist, these are the skills that are important. So it is a combination of mathematics, computer science, and domain expertise. So these are the three big bubbles in which data science can be categorized to. So you need to have some mathematics knowledge, which comprises mainly of statistics. So a lot of statistical algorithms like linear regression, logistic regression, decision trees, k-means, a priori algorithm. So all of these are the statistical algorithms. These are not something that have been devised newly. These are the algorithms that existed from several ages. And so there are other parts of mathematics like machine learning that comes from computer science. Sorry, this is not part of mathematics, but computer science, machine learning. So we learn from data. This is what is called known as machine learning. So there is one learning that we actually provide. This is something that we draw from data and we say that this is what it means. And then there is machine learning where the machine actually learns based on data and it improves itself. So we improve the algorithms. An example would be, so let's say, so if you are a store owner and there are three customers that come to your store and they are all children, and they come to your store and they buy toys. So what impression that you will draw is that since most of my customers are children, I should stock more children stuff. But as you get more people, so let's say if there are two adults also entering your store and they demand for some grocery, then your decision would change. Now you have gained an additional learning that my store is not only for children, I also need to focus on some adult stuff. But since three children out of five were, three of my five customers were children, it makes more sense to have more children related stock and less of the adult stock. But as your data grows, then your learning changes, and this is where machine learning and computer science comes into practice, and you are able to recalibrate your models. Then very important part of data science is about data, where you have the data processing, data storage. That is again part of computer science, that how do you actually store that data and how do you retrieve that data. So we talked about big data there, right? So there is big data, a need for storing data, large amount of data, and retrieving it very quickly. So that is where data processing of computer science comes into practice. And then of course data science will not be complete if you are missing on the yellow bubble, which is domain expertise. So domain expertise is very important, because if you don't understand the domain, then you cannot explain, no amount of mathematics and computer science can explain what is the insight that you have drawn from it. Okay, so I will move on to the roles of the data scientist, the different roles that are played by the data scientist. What are the different responsibilities of a data scientist? So the data scientist is responsible for actually creating a lot of rules. He's one who creates those data models that lays out the results for complex large scale data sets. So there are large data sets that cannot be processed easily, and on those data sets data scientist will be working, and he'll be doing a lot of data modeling, data mining, and research, and coming out with interesting insights from that data. The major responsibilities that a data scientist has is on selecting features, building and optimizing classifiers using machine learning techniques. So what this means is that features are nothing but the variables. So in any business or in any problem, there can be a lot of variables. There can be hundreds or thousands of the variables that are being stored. So for example, like I talked about Amazon, The Amazon is storing customer data, the customer names, their age, their genders, their addresses, their work profiles, their purchases history, their delivery addresses, their transactions, their interests. So a lot of information is there only about customer. Now, which of these parameters or which of these values are actually important and which are the values that are not so important, that have to be taken care. So Amazon might not be interested in what is your salary, for example, even if it has that data. To predict whether you are going to buy a product or not, it might not be interested in your income, even if it is able to obtain it from some sources. What Amazon would be interested in knowing what are your interests and what is your purse size, what is your purchase capacity. So if you have purchased items only within 100 to 500 range, then it would be futile for Amazon to actually recommend a product worth 5,000. So it would make recommendation in only that product categories or in that cost group. So it is very important for data scientists to select the right features and then build and optimize the classifiers using the machine learning techniques. Then a data scientist does a lot of data mining by using a lot of methods. So what is meant by data mining is that a data scientist is constantly involved in doing a lot of data analysis. So when we talk about features or variables, it is on the horizontal side, but then there is a depth of it also. So when you look into the depth of the data, then a data scientist does a lot of data mining, like what are the kind of insights that are there in the data to predict those kind of insights. A lot of data mining techniques are used. Then third is extending the company's data with third-party sources of information when needed. So as I said, for the retail chain example, for example, we had information of point of sale data, that what is the kind of sales that these retail chain stores are making. But we had to go an extra mile to understand the geography of those areas, to find out that these areas, there were more people who were politically influential and they were exerting pressure on these stores to give items for free or as gifts. So this comes when you actually look for sources that are beyond the information that is already provided to you. A lot of time of a data scientist actually goes into processing and cleaning data and verifying the integrity of the data. So it is very important to ascertain whether the data is provided to a data scientist is correct or not. For example, there can be a lot of outliers in the data. So let's say if I have a data set of 100 items and all of these 100 items have values between 1 and 1000, and suddenly there are 5 or 6 data items that have values in excess of 10,000. So these are my outliers. There are about 10 or 20 values that are negative, but they can affect my analysis negatively. So we need to actually remove these kind of data items from our data sets. And since I am giving an example, these are very simple examples. When you have big data sets, let's say data amounting to several GBs, then it is very difficult to find out these outliers or these data items with negative tendencies. So data scientist's job is to ascertain that there is integrity of data, the data is correct, it is cleaned, there are no dirty values of data in that database. And then the major function of a data scientist, or the major role of the data scientist, is to build predictive models using the machine learning algorithms. So machine learning algorithms, they are synonymous with your statistical algorithms, nothing but your statistical algorithms and a fancy name given to those algorithms. And so he uses those machine learning algorithms to build up predictive models that would not only work on your historical data, but also the new data that is generated in real time. We will move into what is the difference between classical business intelligence versus data science. So we have seen it earlier also. Some characteristics of what we do in business intelligence versus data science. The first one is of perspective. So business intelligence is all about looking backward. We look into historical data and see what is the pattern there, but we do not do any kind of predictions there. But in data science, we are actually looking forward. We are not just looking at what is the pattern there and what is the story that data tells and what is the prediction for my business. So data science is more forward looking. Then the data sources. Data sources in business intelligence were usually structured, like I said, SQL, data warehouse, or databases like Oracle. But in data science, what we are looking at is not just structured data, we also have unstructured data. So data can be coming from anywhere. It can be logs from applications, it can be cloud data, it can be SQL, NoSQL, it can be text data, it can be Twitter or Facebook feeds and posts and comments. Any kind of data can be there. In fact, I met a gentleman from public sector. He was a data scientist for railways, and he was telling me that a lot of data that he has to deal with is in registers, it is handwritten, and then there is a lot of data that is available in printed formats. There is a lot of data that is in cyclostyles. There's a lot of data in those handwritten forms that people used to fill for manual registration earlier. So a lot of structured and unstructured data we data scientists have to deal with. Approach in business intelligence is more about statistics and visualization, whereas in data science there is statistics, machine learning, graph analysis, a lot of new technologies that are involved in actually developing those technologies. Focus is past and present in business intelligence, as we said, looking backward, and in data science it is present and future. Tools used for business intelligence were Pentaho, Microsoft BI, ClickView, whereas in data science we are actually using R, Python, RapidMiner, Weka. These are the tools that one needs to master for data science. So commonly used tools. So there are four kind of applications that we typically have in data science. The first one is of data analysis. So R and SAS are two programming languages that are widely used in data analysis. R is an open source. That means it is freely available and it is very extensive. So there are a lot of features. People have built in a lot of libraries and algorithms that are readily available in R. And it is a very growing community. There is always some development happening in R. Whereas SAS is a licensed product and it is used more commercially, and it is used by big organizations like big banks, American Express and Bank of America. So they are primarily using SAS. Python is picking up very rapidly and it is now replacing R. So it is moving forward than R. So R is still the most widely used programming language, but a lot of people are nowadays moving to Python because it is easier and it also provides a lot of flexibility. Now then, Spark is another tool for data analysis that is based on big data. Then there are some data warehousing tools. When we talk about data warehousing, it is more about storage of data. So Hadoop is again another open source tool which is very widely used for storing data, retrieving data. Then SQL and Hive are again some tools that are used to retrieve and operate on data. So they work in conjunction with Hadoop as well. A very important part of data science is data visualization. So it is not only in numbers and figures that we generate insights from data, we actually visualize also. So there are beautiful graphs and a lot of scatter diagrams, histograms, plots, different kinds of plots that we do in data to actually visualize and see that what are the kind of trends that the data suggests. So there are some good tools that help us in data visualization. Tableau is very widely used tool in data visualization, and a lot of data scientists or a lot of people who actually get into data science domain do nothing but data visualization. So there are people who are experts in Tableau, and Tableau is a wonderful tool that helps you do a lot of data visualization using drag and drop techniques, and you can simply drag and drop your columns and rows and it can generate different types of graphs and pictorial representation of your features very beautifully through visualization. Then for machine learning, again, something that we do in data analysis, Spark is a big data based approach. Then Mahout and Azure ML Studio, these are all cousins of Hadoop. Now we move on to the life cycle of data science. We will actually look at how a data science project is executed and what are the steps in solving a data science problem. So this is an interesting example. What if we could predict the occurrence of diabetes and take appropriate measures beforehand to prevent it? And this gentleman is saying that definitely, let me take you through the steps to predict the vulnerable patients. This is a problem statement. What we are trying to do is that we are going to look at different test results and we are going to predict whether that particular person with different test results or different information about his blood profile is likely to have diabetes and if anything can be done about it. So I hope the problem statement is clear, and it's very simple problem statement, and we'll move on to what are the different steps in solving this problem. So the first step in solving this problem is discovery and data preparation. These are the two steps that actually go hand in hand. So what we do in discovery is that we actually look at data and we understand that what is the kind of data that we have at hand. How many values of this data set are numeric? How many values are there that are string? how many values are there which are actually logical, yes or no, true and false. So we look at data and we do that kind of thing. We also do a lot of data preparation in which we see that whether there are any null values or empty values in data that need to be removed or replaced with some default values. What are the some of the outliers that do not look correct and they should be removed if there is the data information that is not relevant. We also do a lot of feature selection. So let's say if we have 100 variables or 100 types of information stored in that data, then which of that information is relevant for our business or use case, which information should be removed from that data. Then we actually move on to model planning, where we identify that what is the kind of algorithm that we need to apply to this data, and we actually generate a model. We generate an equation that explains most of my data. In case of predictions, if I'm making any prediction, then we take 2 or 3 variables or a number of variables that return me a value that can be predicted. So for example, I can take time of visit in a store, the past history of a customer as another variable, and third is whether I am accompanied by my family or not whenever I make purchases, to determine whether I am likely to buy a shirt or not. So this kind of model we develop in model planning phase. Then we do a model building. So we look at some assumptions, we validate our assumptions, and we test it against the data and see whether our model is valid or not. And we check it against the test data. So we have a sample data with us, we have the historical data. We actually take subset of that data for our model planning purpose. And for model building and validation, we actually take another subset of data and test our hypothesis on that data. This is called model building. Finally, we operationalize that data, we move it into production, and my real data is created, we actually run our algorithm on that data, and we communicate the results to our end users. What are the insights or what are the stories that we have found out from that data? What are the predictions that we are going to make for that data? What is the forecasting that we can make based on the data science that we have applied on the data? So these are the steps that are there in life cycle of any data science project. So if you pick up data science project from any domain, it would go through these steps typically. So now we are actually going to detail of all of these phases. I will cover it up so that you understand what happens behind the scenes in discovery. So in discovery, we acquire data from different sources. So data can be coming from logs of web servers. It can be social media data, census data related to population, or data streamed from other online sources. So we combine all of this data from different sources. And then we actually identify that, so for this particular use case, this is the kind of data that we obtain. So on your right side here, you can see that the data is generally available in CSV format, and we have these attributes. So we define these kind of attributes. What is the meaning of these attributes? So NP-reg, for example, means number of times a woman has been pregnant. Glucose level indicates the plasma glucose concentration. BP denotes blood pressure. So we actually look at the database schema and understand what is the meaning of that data, or what are the different kinds of parameters that are present in that data. Again, there's a very interesting attribute called income over here, which has nothing to do with the problem that we are trying to solve. And since you are combining data from multiple sources, it is quite likely that you would be seeing some kind of mixed information in this data. And again, as we were talking about the importance of domain, so if you do not know that healthcare has nothing to do with this kind of particular parameter, there can be some parameters that are not actually related to diabetes, medical terms that are there. So if you are not from that domain, you will have hard time understanding it, and it would be tough to make a decision whether to include it in your problem or to remove it. Next, we have data preparation. So data can have a lot of inconsistencies like missing values, blank columns, abrupt values. So we need to actually look at these kind of examples in our data set and remove these examples. So also find out if there are any outliers. So this is an example of cleaning up from the use case that we have picked up. So you can see in BP, for example, all the values are within 70 to 7200 range or 50 to 100 range. But there is one data item which is 6600, an abnormal data item. So we might need to replace this data item. Similarly, in NPEG, we see that rest of the values are numeric and there is one value which is alphanumeric or string data type. So this row should be removed. So these are the kind of, and again, income is one column that is not required for this particular data set at all. So it should be removed from my data on which I'm doing any analysis. So we clean these values. The data scientist has to clean up these values. So there are different approaches that can be taken. So for example, this high value in BP might be replaced by the average value of rest of the values. The string value was replaced by numerical, and so on and so forth. So then next we move on to model planning. So here we actually determine that what are the tools that we are going to use. We also do some sort of exploratory data analysis where we look at what is the mean size of different parameters, what is the median, what is the most frequently occurring items, what are the type of items, what does data look like prima facie. So we do it in exploratory data analysis, and we use a lot of visualization tools, a lot of graphs to actually understand the kind of data that we have. These are the tools R, primarily R, SAS, and Tableau we use for exploratory data analysis. So this is how visualization techniques show us the data, that how does this look like. So what they have done over here is different parameters. They have drawn graphs for different kind of parameters, for glucose level, for BP, for BMI, and so on. Next part is about model building. Here what they do is, like I said, we separate the data into two parts. There is one part which is called training data set, on which we actually do our model building. We create our model and we test it. We identify the hypothesis, and then there is a testing data set which we use for validation. So whatever model we have built, whether it is correct or not, we verify it on the testing data. So we do it in this phase. So this is the phase where your model actually matures in this particular phase. So we also apply a lot of techniques like classification, clustering, regression, and then again R, SAS, Python, SPCS. These are all the tools that are used for model building. So these are not any different tool. In fact, R, Python, and SAS, these can be used for your exploratory data analysis, your model creation, model validation. You can do everything using one tool as well. Generally, most of the tools are like that, barring data visualization tools like Tableau that are good for doing all of these roles. So this is an example of decision tree. So they have created a classification based on decision tree, and these are the green values that show that the results are okay, and the red values that we do not want to consider for our result. So this is used for when you want to reach into a decision which is a yes, no, or true, false kind of decision. So a person with glucose greater than 127 or glucose less than 154 and BMI greater than 30.9 is likely to be positive, likely to have diabetes. Similarly, a person with glucose greater than 127, and if his pregnancy is greater than 5 months, then that lady is more likely to have diabetes. So these are the kind of insights that you can draw using these kind of models. Of course, these models are not as simple as shown in this example. They can be very complex, and you might have to simplify them or run your algorithm several times to reach into a stage where this model becomes this simple. Next is you operationalize, you derive final reports, briefings, and you do the documentation, and you work on the real data, and then you give the insights to your customers. So this was the last part, that we operationalize, we implement the product in live environment, real time. What you did till now was you took some historical data and you divided it into training and test data and evaluated your model. Now you are actually deploying your model into real time, and whatever new data is being created is added to your problem data set. And then again, your data algorithm is improving itself. You again run your test and see whether in the light of new data that is coming, is my model still holding good? And that is where you actually operationalize it. And finally, you communicate the results. So once you have run it for a good amount of time, then you actually give results to your stakeholders and tell them what are the key findings. You also explain the model. For example, in case of a medical problem that we just solved to predict whether the person has a diabetic or not. So you explain the model, that this is how we have built the model and this is what our predictions are. So let's say if these are the data values, then a person is likely to be diabetic 90% of times. Or if these are the test results, then we are not likely to have people who have diabetes. So these kind of results are explained to people who are actually doing that kind of analysis. So these are the kind of results, and with this we are done on one practical example of how do we solve a data science problem. And here we actually conclude this session on what is data science, and I have explained to you that what was the problem, what was the need to get into data science, and what we actually do in data science, what data science helps us do, what are the different tools that are used for data science, what are the skills that are required for being a data scientist. And then we looked at some example use cases from different industries. And finally, we took this use case, a real life problem statement, where we solved a problem for medical line or medical domain. Thank you very much for joining in.